Alright, we left off last time solving the Galaxy Toys example. And we got this thing out right where it said we produced 480 lots of space rays, 240 lots of phasers for a total profit, weekly profit of $5,040. And then we got the sensitivity report. So we're going to talk about the sensitivity report, but before we do that, what we need to do is think about what this thing looks like. So we have two columns, meaning we have two variables, which means we can draw it in two-dimensional space, so on a piece of paper. Each of the constraints, each row, is going to be a line on the graph, and then we are looking at different areas of the graph. So let me pull up the graph of this. I've drawn this for us. So here I have the constraints listed, the minutes of production labor, the pounds of plastic, the maximum total production, and the production mix. Black, blue, green, and red. And then I drew each of the lines with S on the x-axis and P on the vertical axis. And we see that plastic goes all the way up here, right? What I did was I found 2 points and drew the line. The green total production is out here. Here is the labor, and then the red line, the production mix, is going this direction. And then all of them say less than or equal to, so we want everything that's below the line or to the left of the line in this case. And so we find this area that I've highlighted in yellow is called the feasible region. That means that there are anything within this region, within the yellow part, including on the lines, is a possible solution, one that meets all of the constraints at the same time. So we can't pick something like out here at like 600, 300, right here, because that would be, it would violate all of the constraints. It doesn't meet any of the constraints. We can't pick something here like 800, 0, because it would not meet the plastic constraint or the production mix constraint. It would meet the other two, right? But not that. So 700 out here. So all this area that's highlighted in yellow is feasible. That means how many points in this region are there that are possible solutions? Well, remember, we can have fractions and decimals. So that means there's an infinite number of possibilities within this region. We are looking for the best, the optimal solution. We already know what it is because we solved it. But how does it do it? How does the computer do it? Right? How does the add-in do it? Well, it uses a thing called simplex, and what it does is, for linear programming, we are guaranteed an optimal solution at one of the corner points. So what's a corner point? Corner point is where two or more constraints intersect. So this corner point right here, number 4, I have labeled, is where the plastic, the blue line, and the red line, the production mix, intersect. Right? Here is where the number 5 is where the labor and the plastic intersect. All right. These other ones are, here's the easiest one, 0, 0. That's feasible. We can do that. Right? It meets all the constraints. We just don't make any money doing it. Or where the non-negativity, right? Because we're in the first quadrant. So we have a total of 5 corner points. I started up here, 1, 2, 3, 4, 5. And so what we would do if we were doing this by hand is we'd find those 5 corner points, in this case, and plug them into the objective function, which is what I could do with these. Right here are the 5 corner points. And the one with the biggest, in this case, because we're maximizing, is the one that wins. And we already know that it's the 5th one, 48240. 48240 right here, that's where plastic and labor intersect. So those are the two binding constraints that we saw before, meaning we're using up everything that we have. We're using up all our plastic, we're using up all of our labor. Right? So we're guaranteed an optimal solution at a corner point. So now that we know what the geometry of the problem looks like. We can talk about what happens if we change some of the numbers in the problem, some of the coefficients. How sensitive are the results, our recommendations, to changes in different coefficients?